Hi, I'm Evan Rochon, and we will be hitting a ball, seeing if we can hit a ball over the net using our physics. This question comes from Chapter 3, question 69. The question asks, a tennis player hits a ball 0.53 meters above the ground. The ball leaves the racket at 9 to 10 meters per second and at an angle between 23 and 30 degrees above the horizontal. The horizontal distance to the net is 5.5 meters, and then the net is 0.8 meters high. Does the ball clear the net? If so, how much? If not, by how much does it miss? My hypothesis is that the ball hit at the minimum of both ranges should clear the net with at least a meter of height to spare. Doing the math, we first have to look at the information given to us. We are given the initial height the ball is at when it leaves the racket. We know the initial velocity, we know the launch angle, the distance to the net, and the height of the net. And so in order to find out what we're looking for, which is what height the ball is traveling when it reaches the distance to the net, which is 5.3 meters, we first have to find the time it takes for the ball to travel 5.3 meters. And we find that by using a horizontal function, which we plug in the x, which we know is 5.3 meters, and we solve for time. We solve for time by dividing the initial velocity by the cosine of the angle, of the launch angle. And then we use those numbers we use the time numbers we find for time, and plug it into our y function, which will give us the height the ball is at when it reaches that amount of time. Doing the actual math, we go ahead and plug in the distance of 5.3, and then we divide it by our initial velocity of 10.5 meters per second, and then multiply that by the cosine of our launch angle of 20 degrees. And then we find that it takes the ball 0.53 seconds to travel 5.3 meters. And then we use that time and plug it into our y function, using the same speed and angle, but this time finding the sine of the function. And doing that, we find that the ball is traveling at a height of 0.5269 meters when it reaches the net. Then we add the initial height to the height of the ball, which means the ball is 0.98 meters above the ground, and then we subtract the height of the net, which gives us the ball was traveling 0.59 meters above the net, meaning that it went over the net with 6.69 meters. And now we went ahead and did a real experiment to test our theory. And then we calculated some of the data for our experiment with the software. We first calculated the distance, the horizontal and vertical distance between the ball traveled between frames to try and find our launch angle, the height being 0.1111 and the horizontal being 0.3267. We were also able to find the height of the net and then the initial height that the ball was hit as well. And then we also used the initial velocity of the x and the initial velocity of the y, which we'll use to find the initial velocity of the ball traveling. And in order to do that, we find the square root of the velocity, the x velocity squared plus the y velocity squared, which gives us 10.25 meters per second that the ball was traveling. And then in order to find the launch angle, we find the inverse tangent of the 0.111 divided by 0.3267, giving us a launch angle of 18.78 degrees. And now we plug these numbers into the function that we used before, which gives us a time traveled of 0.55 seconds and the ball traveling at a height of 0.33 meters. And then we add the height of the initial height of the ball, which is gives us 0.79, and then we subtract the height of the net, giving us 0.39 meters that it had to spare while traveling over the net. In conclusion, if all of these things are true, the ball does go over the net. Our hypothesis wasn't exactly correct because we thought we would have more room to spare by almost a whole like 0.7 meters. The differences in our solutions are slight, but that's likely because of the rounded numbers we use for the theory and the more specific numbers we use for the real life numbers, and also air resistance isn't accounted for in our calculations as well. But thank you for watching, and hope you have a good day.